Let us have a look at our DTM or Digital Terrain Modeling application. If you choose your DTM application on the left hand side and you click on the command group called Mesh, you will find all your DTM or Digital Terrain Modeling commands next to it. Let's have a look at something like a two-dimensional contour drawing. The drawing you see currently on screen is a 2D contour drawing consisting of polylines with text entities at the end of the polyline. Now the text entity indicates the height of the polyline. If I do a three-dimensional zoom and orbit, you will see those entities are completely flat or drawn on my WCS. What we want to achieve now is I want to take those entities and convert them into a three-dimensional contour drawing. In CADI 16 we've got a command that says convert 2D contours to 3D. I'm going to choose the automatic process to create those contours. Let's create it within a rectangle, and in the command line you will see it says what is the search radius that should be used to find contours around text. That simply means at each and every end of a polyline, CADI is going to search for a little bit of text, and the text will then determine the height. So in this case, because I'm working with a millimeter unit drawing, I'm going to choose the search radius to be 1 meter. Once you enter that, it's going to ask you to indicate the diagonal corners of the rectangle. So I draw a rectangle across all the two-dimensional contours. CADI will do all the calculations, going through the motions. Once it's highlighted and I do a regeneration of the drawing, orbiting this drawing, you will find that this drawing now is done in 3D. So CADI just created 2D contours and took 2D contours and generated them into 3D contours. Also, another option that we've got in CADI 16 DTM application is the ability to create volume differences or calculate volume differences between two DTM models. If I create the volume difference between, let's say, the left hand side and the right hand side, CADI will do the calculations for you, and in the command line you will see the second DTM is larger by so many cubic millimeters or so many cubic meters. As you can see from this, I did a cut and fill between those two applications, and the one simply has a bigger volume than the first one. Also, when creating a tin model or triangular irregular network mesh, you will find that CADI uses the Delaunay triangulation system. Sometimes the triangles that's created is not completely what you want it to be. As you can see in this exercise or example, triangulation should have been done at the top and at the bottom of the points indicated. If something like this happens, you can choose the command that says swap triangles and indicate the two relevant triangles, and CADI will automatically swap it for you to get you the correct triangulation done as indicated. Another option that we've got on there is on a three-dimensional terrain like this, sometimes you want to find out what the angles of the slopes are within that tin model. So once again, I go to my top view, zoom into this area, and we have a new command in CADI 16 that says color triangles by gradient. So with this example, I'm going to do the selection to be a rectangle. Let's say between 0 and 10 degrees I want to use pen number 73, between 10 and 20 degrees 105, 20 and 30 even a darker green color, 30 and 40, 40 and 50, 50 and 60, etc. You can add as many rows as you like with any interval that you please. As soon as you say OK and CADI asks you or prompts you to indicate the diagonal corners of the rectangle, you simply just drag a rectangle across the DTM model, and on screen you will see it colors all the gradients of the DTM model by the colors that you've specified. So you can immediately from this gather and see whether certain areas are suitable to place either your building or do a road design or services or whatever. And obviously the steeper areas you can avoid, because that's going to be not that cost effective. Also, once you have a DTM model, you can create contours from a tin model or DTM model. It says select entity's first corner, so I just drag a rectangle across the area that I want to generate contours of. It will ask you what's the minimum contour height, the maximum contour heights, the first major contour height, your contour intervals. In this case, as you can see, my drawing is done in millimeters. The colors you wish to use. The new option that we've got in CATIE 16 as well is you can choose whether you want your contours to be drawn as splines or polylines. Polylines will give you a more ragged edge, where splines will give you a more fluent curve. So let's just choose splines for now. You can also choose text labels to be added, or you can omit the labels to be added. Once you say OK, you will see by switching the three-dimensional entities off, you will see generated contours for you, and in this case as splines, which gives you a much more flowing and even flowing contour drawing. Also, getting back from that point on the DTM application, this area that you see in front of you currently is a three-dimensional contour drawing. Now, to create a tin model from that, we require some three-dimensional or construction points in a 3D environment. We also have in CATIE DTM application a command that says draw and export points. Once I click on that, in this case I'm just going to tell CATIE to draw the points, not to export them, within a rectangle, and the minimum distance between the points you can specify to be 5 or 10 meters. So whatever spacing you want in between the points, you can enter that in there. Once you say OK and you indicate the rectangle itself, CATIE will do a contour count and tell you there's so many contours, so many points it's going to add. Do I wish to continue? Once I click on yes, it places all the points in front of you. Let's just switch the lines and curves off, and you will see orbiting around this model, all the points are also placed in 3D. Let's go back to the top view again. Once you've got the points in 3D, you can do a normal triangulation on those points. Let's just choose a different color so you can see the points more clearly. Once you do a triangulation and I indicate a rectangle to triangulate, CATIE will do all the calculations for you and generate a tin model or DTM model for you. In this case I'm going to switch the points off again, and you should have a three-dimensional object in front of you. So, taking everything that we've done so far, it simply means once you've got a two-dimensional contour drawing, you can convert the 2D contours into 3D contours. From the 3D contours you can generate points, and from the points you can generate a tin model. So those are the enhancements that we've done in CATIE 16 regarding the DTM application.